Imagine an inhospitable planet with some of the worst conditions known to mankind. It has an astounding estimated temperature of greater than 1800 degrees Fahrenheit, which is almost enough to melt pure gold. Due to atmospheric compositions, it rains small diamonds which are then hurled around at wind speeds of 4.5 thousand miles per hour. This is planet HD209458b. Before we find out more about this planet, we will need to establish some basic facts about it. Measurements of this planet are often compared to Jupiter because they are both gaseous planets. However, the comparisons below will be made against Earth. Planet HD209458b has a radius 1.38 times bigger than Jupiter and 15.5 times the radius of Earth. Furthermore, it has a mass 219 times bigger than Earth, but it is only surprisingly 69% of Jupiter's mass. Using the information previously mentioned, we are able to use the equation acceleration of gravity equals big G little m over r squared. After plugging in all the numbers, we get the acceleration of gravity to be about 8.94 meters per second squared, which is slightly less than Earth's 9.8 meters per second. Building off this, if there were to be a satellite orbiting this planet at 400,000 meters, its orbital velocity would have to be around 29,000 meters per second in order to keep it in orbit. We can find this using our previously mentioned measurements in the equation v orbital equals the square root of big G big M over little r. With this new knowledge, we can use the distance that the satellite travels in one Earth day and divide it by the planet's circumference to find how many orbits per Earth day it accomplishes. After plugging in all these numbers, we get about 4.122 orbits per Earth day, which is dramatically less than the ISS's approximate 16 orbits. We can also use the equation t squared equals 4 pi squared r cubed over big G big M, which gives us the same result. The planet HD209458b was discovered in 1999 due to a dip in brightness from the exoplanet Sun. By a shockingly small decrease of 1.5%, the astronomers David Chauvignat and Gregory Henry were able to label it as the first extrasolar planet found through the method of measuring its transit, or passage across the Sun. Using information like this, we are able to estimate the distance between the star and the planet's center, or its semi-major axis. Since the semi-major axis is measured in astronomical units, we can use the process of dimensional analysis to convert the semi-major axis of 0.4747 astronomical units to meters by multiplying the length of 1 AU in meters. This comes out to be just over 7 billion meters, which is much less than the 149 billion meters between the Earth and its Sun. That distance is also what scientists use to define 1 AU. That we used earlier to find the satellite's orbital velocity, we can calculate the orbital velocity of our planet to be about 146,000 meters per second. If you're curious what this makes a year on the planet, we can find the circumference of the planet's orbit and divide it by the distance the planet travels per day to find out how long a year is, which is only a stunning 3 days.